Okay, I've said it a couple of times before. I'm going to say it again. U3A4 is going to be the important activity here to summarize all this. So U3A2, the big thing there is looking at kinetic energy equals half mv squared. So if something is moving, you use that formula. If you want to know the energy when something is at rest, we use mgh. That's potential energy. Think of it this way. If you want to know how much energy this object has, if it's just being held stationary up in the sky, we would want to know how much mass it has. So if we put something down here like a grape and we dropped that brick on the grape, the heavier grape is going to have more energy. It's going to do more damage when it hits that grape. The other thing that's important is the height. Now, the higher this is, the more damage it's going to do. So the more potential it has to do work and to crush that grape. Now, it's important to note that our gravitational constant, no matter where you are, is 9.8 meters per second squared. So if we're in Earth and we're within range of our atmosphere, that constant is not going to change. 9.8 meters per second squared. So this is a constant for gravity, and we've talked about gravity earlier in the course. I want to show you where I say that energy and work, these two terms can be interchangeable. We say work is equal to a change in energy. Look at your formula for work. Work is force times distance. Force is mass times acceleration. Now we have mass times acceleration times distance. Well, gravity is a form of acceleration and height is a form of distance. So in other words, we have the same formulas here. Folks, I'm not going to go into too much detail here for this U3A3. The very important one marks-wise, there's going to be a quiz and there is also going to be an activity is U3A4, and what we're going to do in U3A4 is we're going to marry the whole idea of the energy of movement and the potential energy and make those two work together.